Our next speech will be OpenStack Octavia Load Balancing as a Service project update, and our speaker will be Michael Johnson. Michael is a founding member and the current project team lead for the OpenStack Network Load Balancing project, Octavia. He's currently a principal software engineer at Redhat. Michael lives in Corvallis, Oregon, in the United States. And I want to thank him very much for joining us because it's early morning in this time zone. And I want to thank him for joining us at 6 p.m. actually in his time zone. Ladies and gentlemen, please welcome Michael Johnson from Redhat.
Hello, thank you. And good afternoon. Go ahead and start sharing the screen here. So today I'm going to talk a little bit about what we've been doing on the Octavia project. So as you heard in the introduction, Octavia is network load balancing for OpenStack. And we're a pretty active team. We're a small team, but a very active team. So we have a lot of new features to talk about today. So in case you're not familiar, Octavia provides a scalable, on-demand, self-service network load balancing component to OpenStack. It also supports plugin drivers. I think we're up to about 7 plugin drivers for various vendors today. The reference driver, which you'll hear me talk about, is what we call the Amphora driver. That's a purely open source software-based load balancer implementation that scales with your compute. We actually spin up service VMs to provide that load balancing capability in the cloud. The project started in Juno release of OpenStack, so one of the younger ones, but definitely growing. Continuing pretty average contributors, not a lot of change there. We've brought in a couple new cores in the last Victoria cycle, but pretty much staying flat. And we're a spin out. We spun out of Neutron in the Okada series and became a top level OpenStack project on our own. So let's get into some of these new features. So going back a little bit in time, this is an important one that people really like and have been using quite a bit. This is log offloading. So inside that service VM, or Amphora instance, we've now enabled syslog offload of the logs from those load balancing engines. So you can send your administrative logs, things like the load balancing engine logs and such, to one syslog target. And you can also offload all of the tenant flow logs. So all the connections that are occurring on that load balancer instance can be forwarded off and maybe presented through a log stash environment that you may have in your environment. So the log format, this is an example here. It's a lot of data, but it kind of breaks down. That bottom section is kind of the key to all of those fields. But you can break out and see what they requested, where they were coming from, what the status of that connection was, how long it took to service, etc. So people are really enjoying this feature and getting a lot of use out of it for providing real-time feedback to end users on what's going on with their load balancer. Also, something we added in Train, it was a much requested feature, probably too long in coming, but you can now apply access control list to your virtual IP of your load balancer. So this basically says you can restrict what the source IP address ranges are, the CIDRs that are allowed to connect to that virtual IP on your load balancer. So it's an added layer of security on your load balancer where before, if you wanted to restrict who could access it, you used maybe a private tenant network inside Neutron. Now, if your VIP lives on your public or external network, you can control that access. The other nice advantage is this is implemented using security groups from the networking driver. So in the common example, that's Neutron. So that means we're actually blocking the traffic even before it gets to the load balancing engine itself. So you can control any incoming issues that may be impacting the performance of that load balancer before it even hits that service VM. The command line pretty straightforward when you create your listener, and this is per listener. You can have different access control lists per listener. When you create that listener, you can add in the list of allowed classless domain citers, basically, that will be allowed to connect into this virtual IP. Quick. So moving on to new features in Usuri. So we partnered with the OpenStack Foundation and the North Dakota State University to host some students. We had 4 students that were part of a senior capstone class. And so they had a semester to contribute to OpenStack. And so we mentored them, and they were able to provide 2 features to Octavia in that time frame, which was outstanding. As anybody knows, coming up to speed on OpenStack can be quite daunting, and getting them up to speed and contributing code in that period of time was pretty cool. But down to the feature. So this allows users to specify the individual TLS ciphers that are accepted on a terminated HTTPS load balancer listener. So when you're doing TLS offload on the load balancer itself, you can now specify those individual cipher suites that you want to use or accept on that listener. So this is really great if you have certain compliance things you need to meet for the level of security connecting into your applications. You now have very fine-grained control over that cipher suite. As part of this change, we've decided to switch the default over to the Open Web Application Security Project's broad compatibility string B. So that's a list of ciphers that they feel are reasonably secure, but also widely supported across browsers. But this is operator configurable. So you, as an operator deploying Octavia, can specify your default string in your config file if you want to tune that. And then finally, we've added a feature there that allows you as an operator to list certain ciphers that are banned, that you don't want users to be able to select no matter what. So you can build that list up in the config file as well. And we will block any listener create or update that attempts to use that cipher. So just an example here, again, creating a listener. I'm adding a very short list of ciphers. If you've seen the lists, they can get quite long. But this is an example using AAS 256. Moving on, another feature that a lot of people are excited about, and we have a couple customers using today, is availability zones. So, OpenStack's had availability zones in the compute engine in Nova for quite a while. This pulls that forward and allows you to define availability zones in Octavia. The definition of that availability zone, as you can see here, has 3 components today. One is the compute availability zone, so the AZ that you have configured in Nova for this deployment. The management network, so how does Octavia reach those service VMs and manage them and collect metrics and information about them. And then the valid list of VIP networks that are available in that AZ for the load balancer. So talking a little bit more about the management network, since day one, Octavia supported routed management networks. So you can have multiple management networks in your deployment as long as the controllers can route to them and get access to those Amphora or those service VMs, and they can get back. That's valid in Octavia. So this is a great opportunity to use like an IPv6 deployment where you can set up unique management networks in each of your AZs for deploying these load balancers. Once you've defined the availability zone through building this profile and then defining the name and information about the availability zone in Octavia as an operator, then users can select that at load balancer create time. So as you see here, someone's created an availability zone. They called it Tower 1234. And when users go to create a load balancer, if they want to target that load balancer to that specific AZ, they'll pass that in on the command line or through the API as an added parameter. And then we'll do the right thing in booting up those service VMs in the right environment. Really powerful for large deployments. Moving on, this has been a large focus for the team, and particularly Anne on the team from Marantis. So this is something we've wanted to do since very early in the project, but we knew it was a lot of work, so it kind of got delayed. Octavia is built on top of a workflow engine that was developed for OpenStack. It's called TaskFlow. It's an Oslo package. So if you're not familiar with it, you can go dig around in the Oslo documentation. But essentially, all the provisioning we do in Octavia is defined as a series of tasks that are then put together to create a flow to create that action, that provisioning action. So for example, when we create a load balancer, there's a very large flow of tasks that go into booting service VMs, connecting network ports, setting up security groups, configuring the load balancing engines, etc. Well, Jobboard is a feature of TaskFlow that we hadn't previously been using, but we're bringing into this new driver. So we've cloned our main open source Octavia or Amphora driver, sorry, and created a version 2 of that so we can develop in parallel. And essentially what this does is it looks at that flow, and for every task in that flow, it will save the inflow data, so information that we're storing in the flow and passing task to task, as well as the current state of that flow in a persistent store. And then the Jobboard piece is a component that basically monitors the progression through that flow and assigns tasks to specific workers in your control plane. So the big win here is now if we have a situation where a control plane instance completely dies, falls out of a rack, or as we got a photo here from the Barcelona summit, Mark comes and starts cutting your cables, the Jobboard will notice that that flow is no longer progressing. And it knows what task it was previously on. It knows all the state data that was in that flow. And so it will reschedule that in-progress provisioning to an alternate controller. So this is kind of taking control plane resiliency to a whole nother level of being able to pick up right where we were in the provisioning process and continue to provision that load balancer that a user requested. So very cool technology. It's also a lot of work, and we're still stabilizing this project. That's why it's not the default driver, but it is available for experimentation. Today, we're using a new MySQL database for the flow data persistence. So just creating another database on your existing OpenStack MySQL environment. And then the piece that's new to Octavia is we use either Redis or Zookeeper. This is a configuration choice for tracking those flow states. And so this would be a new component or a new requirement for Octavia if Jobboard's turned on. If Jobboard's not turned on, those are not new requirements. Everything still behaves the way it does today in Octavia. So right now, we consider that a tech preview feature. Even in Victoria, we're still working on that. But we're really pushing to make that the default driver in Wallaby. We'll leave that Jobboard component turned off so we don't have those extra requirements in your cloud until you're ready to do that. But we want to make sure that we're working on one consolidated code path and source code set. So it'll simplify the development side for us, because right now we're maintaining 2 different drivers all at once. So really cool feature. We're excited about this. A lot of work's been going into this. So let's jump ahead. What did we accomplish in Victoria? So this is kind of a sneak peek preview of what's going to come up at the summit when we do our project update there. So the other half of the student activity that we did with the students from North Dakota State University is TLS versions. So again, for compliance reasons, you may have a need to restrict which TLS versions you can accept on your load balancer. So right now, the industry feels that TLS 1.0 and 1.1 are no longer considered secure enough. So this is the exact reason to expose this and allow you to configure which versions are supported on your virtual IPs. We've set the default for 1.2 and 1.3, again, following that guidance of kind of what's the best practice today for what TLS versions are safe to use. This is, again, this default list is configurable for the operator. So if you want to expand it to a larger set, that's fine. And again, we've also added the capability to set a minimum version so that users are restricted to only using a certain version or newer of TLS for their listeners. Both of these features, the ciphers and the versions, I should mention, both apply to incoming connections on the listener, but also on our backend re-encryption when we make TLS connections to pools. So it's kind of an end-to-end. You now have control over the security levels when you're using TLS offloading. Also new in Victoria, Proxy Protocol version 2. If you're not familiar with Proxy Protocol, it was developed by the HA Proxy team. But essentially it allows us to insert information about the client into TCP connections. So when you're using an HTTP load balancer, we typically do this by inserting additional headers into the request stream. So the backend servers can see who the original IP address was, what ports they were connecting to, other information that may be lost in a full proxy type load balancer. So Proxy Protocol brings that capability over to TCP. And so when the TCP connection is established to the backend servers, it prefixes that connection with the client information. So we've had support for version 1 of Proxy Protocol for quite a while. Proxy Protocol version 1 is a text-based implementation. So the data that gets passed back in that TCP prefix is all text. And that can be a little bit of a problem for overhead and parsing, especially when you have IPv6 strings. Those are quite long and can take a little effort to parse. So version 2 enhances that. It's a pure binary protocol and allows a much faster connection establishment to the backend servers and sending that information across. It also exposes some of the SSL information that wasn't exposed with Proxy version 1. So if you're not using HTTP for a listener or a pool, Proxy v2 may be of use to you for passing all of that client information back to your backend servers. Many of the frameworks support this protocol. Another feature that a lot of people are going to be excited about, we're finally able to bring HTTP 2 to Octavia. So this was delayed a bit because the distributions that we use for those service VMs did not support the version of our load balancing engine, which is HA Proxy for the most part, didn't support a version that had HTTP 2 in it. But now with the new releases coming out, people have pulled in HA Proxy 2.0 into those distributions, and so now we can start enabling that as well in Octavia. So what we've added is an application layer protocol negotiation setting, which allows TLS terminated listeners to negotiate with the client which protocol is appropriate for the connection. So currently we support 3 different protocols. So HTTP 1.0, very old. 1.1, which is pretty much what most of the traffic is today on the internet. And then H2 is the designation that was given to HTTP 2. So now you can enable that as an accepted protocol on the listener, connections coming in, we'll negotiate and we'll use the best protocol that the client can support. At the moment, this is only on the listener side, and I'll talk a little bit about that for Wallaby on an upcoming slide. When you're using HTTP2 listeners, we highly recommend you have an Amphora image that's 2.0 or newer. It is there and does function on 1.8 HA Proxy version images, but a lot of the capability was enhanced in 2.0 and going forward. And so we really recommend that if you're going to do a lot of HTTP2 connections, that you run with a 2.0 or newer HA Proxy inside your Amphora image. Just to give you a little context, the current long-term supported version is 2.2, and 2.3 is under development now upstream. Another good chunk of work, one of our core companies had some interns that came in and helped them out in reworking our statistics. So historically, we've had aggregated statistics available through our API. So things like bytes in, bytes out of your load balancer, etc. Those are going to remain in place. We're not changing that in the API. But behind the scenes, we're making some enhancements to make this more flexible going forward. So historically, Octavia sent the whole numbers for the statistics back from those service VMs. And that makes it hard to do things like time series databases or billing. So we've switched that over in that protocol so that the Amphora instances are now sending deltas for a lot of those numbers. So that gives us some advantages on our side, but also sets us up to allow some better integration with time series databases or billing systems. And to support that, we've changed the way our statistics are handled inside our health manager process. So now you can have a pluggable list of drivers, and all of those drivers will get all of the status updates or the statistics updates from the Amphora. So this way you can have multiple drivers plugged in. They will all get the data. Some of your drivers may send them off to a time series database or off to some other statistics aggregator. And the others will, of course, maintain the database and the current API statistics that you have today. So this is really cool. We have one big user of Octavia that has a proprietary driver already, and there's a proposed InfluxDB driver, so time series database, that's proposed for the Wallaby release. So we're really looking forward to that. I think we're going to see a lot of interesting progress on handling metrics and statistics in Octavia going forward. Also, something that people are excited about, again, now that the distributions are shipping a 2.0 or newer HA Proxy, that means our main load balancing engine can now vertically scale a lot better. So historically, our Amphora instances are a single vCPU core, which gets us quite a bit of performance. You can get a fairly significant number of connections per second, and I've seen people saturate a 10 gigabit network port with pure TCP flows with a single core. But there are cases where you will want to use or have more CPU power available inside your load balancing engines. So with 2.0, if your Amphora image supports a 2.0 or newer HA Proxy engine, we'll automatically pick up and use those additional cores that you allocate to your Amphora. So just to talk a little bit about our previous feature flavors, that allows operators to define customizations that users can select from at load balancer creation time. So now you can combine flavors where you may have a flavor that has, one CPU, or you may have another flavor that has 2 or 3 CPUs. You can combine that with HA Proxy 2.0. It'll automatically detect those extra cores and will start balancing the traffic and the load across those additional cores. So this adds vertical scalability. For the most part, this is important for people that are doing TLS offload or have very high request rates going into their listeners. So shifting gears and looking forward to Wallaby. So this is kind of, again, a sneak peek. Things that we know are kind of on tap and being worked on for maybe even an early land in Wallaby. So we've started testing on ARM64. We're one of the first projects in OpenStack to do that. We're stabilizing that right now. The OpenStack Infra, OpenDev Infra, I need to switch that terminology, now has ARM64 instances available for us to use, and so we've started leveraging that. And so we can boot the whole Octavia stack out on those ARM instances and prove out that we don't have any compatibility issues with that alternate architecture. Right now, they're running in nested virtualization. So there's some software emulation in there that makes it a little slow. Hopefully at some point we'll have some bare metal that we could also use. That's always been a goal of allowing Amphora to be run on a bare metal ARM platform because it's a very cost-effective and scalable way of deploying the service VMs. So yeah, we've started testing this. We will probably make this non-voting gate here pretty early in Wallaby. We're just working out a few little issues with the infrastructure and package availability. Also proposed for Wallaby is compression support. So basically when you create a load balancer, you'll be able to define what kind of compression you want to accept on the front end, and we'll pass that through to the back end. And if the back end doesn't support that compression or doesn't compress the response, we'll offload that compression at the load balancer, the service VM level. Initially, we'll be supporting deflate and gzip, and you will have the flexibility of defining what mine types get compression applied to versus others. So, for example, already compressed like gzip content or images, this compression doesn't really help. In fact, it can make it larger. So you want to define things like style sheets or your HTML that would maybe benefit from compression as it goes through the load balancer. So work to add this has already started. There's a patch started on our library for adding this, so I expect to see this land in the Wallaby timeframe. And finally, new protocols. So work's already started on stream control transmission protocol. So the API work merged in Victoria. Now we're just working on the implementations. So currently none of the drivers implement it, but we expect that to land very early in Wallaby. Finishing up the HTTP2 work is the back end, ALPN. So then we'll be able to do pure HTTP2 end to end. It just didn't quite make it in time for Victoria, unfortunately. And then once that's enabled, we'll have automatic support for gRPC. You'll be able to do that with a pure HTTP2 load balancer. And then finally, we've had some proposals for other health check protocols. We're considering MySQL, Postgres, Redis, SMTP, etc. Feedback, of course, Q&A here in a minute. We have weekly IRC meetings. We have an IRC channel on Freenode. And of course, the OpenStack Discuss mailing list. If you tag it with Octavia, someone from our team will see that. So I wanted to open it up and see if there are any questions. I don't see any on the conference chat.
Okay, Michael, thank you very much for your presentation. I have a question about log offloading. in order to do log offloading, do we have to add any specific configuration to our Amphora image, or is it possible to do that over API?
So all of the configuration inside the Amphora is handled by Octavia. So you will configure those settings in your Octavia conf, and then as the Amphora are deployed, or if you fail them over to redeploy them, the Amphora will automatically be configured. So you don't need to get into the Amphora for that configuration. It's all on the control plane.
Amphora image will work then?
Yes.
Okay, thank you. I'm looking for other, there are lots of thank messages for your presentation. I don't see any question for you. I really thank you for joining us at 6 p.m. in the real morning.
Yeah, no problem.
Okay. Thank you, Michael, very much for joining us.
Thank you for having me.